Now the session started. Yesterday we discussed about two friends, copper and the steel. So, for example, say copper is having a good strength and the steel is having very poor strength compared to the copper. I'm talking about the friend. I'm not talking about copper and steel as both the materials. So copper is trying to pull the steel to the canteen and steel is trying to pull the copper to the classroom. But unfortunately, as copper is having high strength, so it can carry steel to the canteen. Steel is comparatively having less force or less strength, so it can carry copper to a very low intensity toward the classroom. So look at the intensity. Initially, they both are at this position. Copper is having that much tendency to pull. Steel is having that much tendency to pull. Copper is having that tendency. Due to the different forces, they both are decided that we are not going to the canteen and we are not going to the classroom. It is based on the thermal coefficient of expansion. The copper is having good thermal coefficient of expansion, so it has a tendency. It is soft material. It has a good thermal coefficient of expansion, so it can uh, expand more compared to the steel. So alone copper will be expanded that much. Alone steel will be expanded that much. Now, in order to come to the thermal equilibrium, steel will pull that copper to backward. Means actually the copper has to elongate to that much distance from this to this distance. That is delta C. But still pull that copper to backward. Still pull copper to backward. My point is steel exert compressive force on the copper. So instead of moving that much or instead of having elongation of that much, it only elongate from this original position to that position. Why? Because steel is applying compressive force on the copper. In opposite, steel has a tendency to elongate from this point to this point only. That is delta L of C. But copper apply a tensile force on the steel so that it extend the steel again from this point to this point. So that is sigma C L of C, sigma S L of S and E of S. Are you getting my point? Actual copper किती एक्सपांड झाला पाहिजे अलोन फिक्स पॉइंट पासून इथपर्यंत. स्टील किती एक्सपांड झाला पाहिजे फिक्स पॉइंट पासून इथपर्यंत. म्हणजे टोटल दोघांमध्ये किती एक्सपेन्शन झालं पाहिजे फ्रॉम दिस पॉइंट टू दिस पॉइंट इज द एक्सपेन्शन ऑफ कॉपर दॅट इज delta L is equals to PL upon E. And this is again that much is equals to delta L is equals to PL upon E. But because of the thermal equilibrium condition, as both the materials are connected together, they both are put one another, they are applying forces on the one another and they come to the equilibrium position. Because of that equilibrium position, copper is subjected to compressive force and steel is subjected to a tensile force along with the temperature stresses. Everybody, you are getting my point. मी जे बोलतो ते समजलंय तुम्हाला. This point is clear to everybody. If this point is clear, then give me a thumbs up. If any doubt, ask me. This slide is very important. Apart from that, there is nothing. Only there is a few formulas and the calculations. What I told you, everybody understood. If understood, then ping in the chat box. Understood or clear. If any doubt, then tell me. Then you can ask me fast because today I have to finish that unit. Am I audible? Clear, sir. Krishna Nikam is saying clear. Only one student is saying Bagulo. Okay, only two. Dhananjay Khana, three. Okay, okay. Nikam Pratik. Okay. Ahir. Dhananjay. Okay, okay. Okay. From girls, Avishkar. Okay. Rahul Sorone. From girls, शीतल जगताप आहे का आज? शीतल जगताप आहे का? शीतल जगताप नाही वाटतं. अंजली संत आणि दिव्या आहेत. नूतन पत्र. ओके, गुड. I guess this is clear to everybody. Yeah? Now moving on. Now what exactly happened over here? We'll be looking for. As two members are connected together, the final elongation, that is delta L, will be the same for the both as shown in the figure. Both the same means both the structural members are connected together. It means whatever the elongation or compression held on them, net change in the length of both the members will be the same. The net change in the length will be the same, is delta L1 is equals to delta L2. Now, in that case, there are two different materials, that is copper and steel. So I am going to write over here the delta L of C is equals to delta L of S, because both material connected to one another. Now, this is delta C and delta S. That is nothing but the net deformation, but that deformation is caused because of two different forces. Number one is the elongation due to the temperature difference, and second is the elongation due to the forces. Forces means which forces? First point is elongation due to the temperature difference, means the both material will expand because of some temperature difference. And second force means whatever the tensile force is exerted by the copper over the steel is the first force. And second force is whatever the force applied by the steel over the copper. My question is for you. Which force will applied by the steel over the copper? And second question is which force is applied by the copper over the steel? Give me the answer in the chat box, or you can unmute and talk to me directly. If you are getting me, so it is very easy for you to answer me in the session. Are you getting my question? Mother, are you getting my question? Have you understood what I am trying to tell you? Anybody? Yes or no? Anybody? Yes or no? Steel, side line is saying steel over the copper is a steel over the copper, the compressive, and copper over the steel is the tensile. Very good, Sai. Very good. Sai Dang is saying perfect answer. Okay, so only one answer is there. Huh? Everybody has to be very interactive. Yesterday I told you. Means Sai Dang is getting what I am trying to convey. Anybody else? Means nobody else, means everybody is agree with me and Sai. Okay. So there are two different forces. Just now Sai told us. Now this is delta L is nothing but that delta L is because of the temperature difference, and that is PL upon E. PL upon E means PL upon A, or P upon A is nothing but a sigma. So I have written that formula as the sigma is LS upon ES. So this is first force, that is the elongation due to the temperature difference, and that is nothing but the because of the tensile or compressive force. Now that steel is subjected to tensile force, means that first elongation is due to temperature difference, and that second elongation is because of the tensile force applied by the copper. Both are added because one is a tensile force, because of the copper applies the tensile force over the steel, so that is why it is a plus. In second case, it is delta L of C. It is a elongation due to the temperature difference, and that is delta PL upon E is minus. Why minus? Because compressive force is applied by the steel over the copper. Compressive force means reduction in the length, so that's why it is a minus. Now I'm just going to rearrange the term. So delta L of S, here it is plus, delta L of C is minus. So I'm going to rearrange the term. Delta L of S. Okay, so delta L of C minus delta L of S. I'm just putting on that side. Delta L of C plus delta L of S. Now here it is plus sigma C, sigma S, LS upon ES. Here it is a minus, so once it comes to that side, it will be plus. Okay. Now, as the length of the both the material will be the same, that is LS would be equals to LC. So we can make it common. And over here, I'm going to withdraw the common terms. That is, from this equation, I'm going to withdraw L of C is equals to L of S. So I'm going to replace LC and LS by L only. And on that side, that is the expansion due to the temperature. So it is nothing but the L alpha T. Delta L is equals to L into alpha into delta T. That is the free expansion due to the temperature difference. So I'm going to replace that term by means of L into alpha into delta T that we have seen in the previous numericals. This term come from delta LC and delta L of S are the free expansion due to the temperature difference. And how we are calculating the free expansion? That is L into alpha into delta T. So from delta T, temperature difference will be the same for both. So delta T will be common and L will be the common for both. So I'm going to withdraw L and delta T as a common. And from above equation, I have withdraw L as a common. From LHS and RHS, I'm going to cancel L. So the term remains there, sigma S upon ES plus sigma C upon EC is equals to L will get cancelled. So delta T into alpha C minus of alpha S. This is the desired equation when the two material are joined together and subjected to temperature difference. That will be the net variation in the stress and strain in the structural member. Whereas whatever the amount of the compressive force and the tensile force exerted by the material are equal. Whatever the tensile force and the compressive force exerted by the material over one another is a same. So that's why I have written over here sigma C is equals to PS is equals to PC. Because reaction is same, whatever the forces and tensile force or the compressive force applied by the copper over the steel or steel over the copper, the magnitude of the both the forces will be the same. So I have written over here PC is equals to PS. In terms of stresses, it will be stress is equals to force per unit area. So I have written force is equals to stress into area and stress into area. So these are the two important formulas that we are required for the numerical solution. I guess this is clear to everybody. Those students who understood these things and this diagram, they can easily solve the numerical. So if any doubt in between this, please tell me. If anybody is having any doubt, please tell me. If anybody is having any doubt, please tell me. No doubt? So shall I move ahead? If okay, if it is okay, then ping me okay in the chat box. If up till now it's okay, then ping me in the chat box. Nutan Kachwe, Anjali Santa, Divya Hire. Okay. Dhananjay, Sahil. Okay, very good. Now you have to, I'm going to share this formula with you. So it is very easy for you to understand, and if in case we require, I have shared formula with you that may require us for the numerical solution. So have a note of this. Okay. Then, okay, so let's move towards the numericals. Let us move towards the numerical. This is the numerical. Try to understand only one numerical. It is very easy for you to solve the other numerical. Very easy part. A hollow steel tube of 30 diameter. Simultaneously, I am going to write what is given to me. A hollow steel tube of 30 diameter. A hollow steel tube of 30 diameter. So capital D is given to me, 30 and 5 thickness. So T is given to me, that is 5 Enclosed centrally a solid copper bar of 15 So enclosed centrally a copper solid bar. So I'm going to write that as a small d, 15 to which it is rigidly connected at each end if a temperature of 10 degrees. So first temperature, that is T1, is given to us, 10 degrees Celsius. There is no longitudinal stress will be developed. Find stress in metal when heated to 200 degrees Celsius. So that is T2 is given to us. E of S, that is modulus of elasticity, and for steel, and modulus of elasticity for copper is given to us. Alpha for S and alpha for C is given to us. Okay, so these things are given to us, and they told us to identify. Find stresses in each metal, means two metals, so we have to identify the stresses. So copper and steel, we have to identify the stress in the steel and stress in the copper. So this is given to us. Now from that, you just tell me if the diameter of steel is given to us. So it is external diameter of steel is given to me. So what is the internal diameter of steel? What is the internal diameter of steel? Tell me the answer. This condition is, this figure is given to me. So what is the internal diameter of steel? Waiting for your answer in the chat box, or you can unmute. If you understood these things, tell me the internal diameter of steel tube. Sahil Dange, 25. Nilesh Kuwar is saying Dangi, Bagul 25. Okay, so many people are saying 25. Sahil Dange 25. So everybody is agree with the 25, then give me a thumbs up in the chat box. If it is 25, then give me a thumbs up in the chat box if everybody is agree with the 25. Nutan Kachwe, okay. Krishna Nikam, okay. Everybody, fast. Nikam Pratik, fast. Everyone has to be active. Huh? Everyone. Okay, Pansare, okay. Very good. Quick. Okay, so let me check. So your answer is wrong answer. You are saying 25. Better look at over here. This is a steel tube. It is having external diameter of 30. And the thickness is 5. So it is 5 and it is 5. Na? So 10 is reduced. Na? So 30 minus 2 into 5. It is equals to 20 now. How you are saying this much? This is 5 thickness. This is 5 thickness. So 30 minus 10 is equals to 20 now. Everybody has to be very active. Huh? You have to be very careful about this. Numerical are very easy, but it needs some focus and concentrations. Okay, so okay, that much thing we have T1, T2. So T1, T2 we do have. So can anybody tell me the delta T? Delta T. If I do have delta T1, T2, so can anybody tell me delta T? It is 200 minus 10. It is equals to 190 degrees Celsius. Okay. This is given to us. Let's move towards the solution. Okay, so this is given to me. These things are given to me. Yeah? Okay. So this is given to me. This is given to me. And this diagram is given to me, and from that I have to calculate this. When such a case is there, when the materials are connected in parallel, this is nothing but this is the case where the material is connected in parallel, means the tube, this tube is parallel with this tube. So what we are looking for, we are having the numericals of the parallel case. In that case, just now we have studied what will happen. So what we have studied now, we have studied the case of parallel. The copper is connected in the parallel with the steel. Copper is connected parallel with the steel. So what are the different formula that we have studied? We have studied these formulas. Okay, so let us have utilization of this. So I'm just making a copy of that formula, copy, and I'm going to put that formula somewhere else. Okay. I'm just going to make this. Okay. These two formulas are there. So now what I'm going to do, I have, if I wish to calculate this stress and this stress, means I record this formula. And this from this modulus of velocity is given to us, delta t is given to us, delta t is given to us, alpha is given to us. So means our target is to identify the sigmas. Once we know the sigma 1, sigma, then we can easily identify the values. Now I have one relationship, that is PC is equals to PS, or copper forces acting on the copper is equals to forces acting on the steel. That is sigma C into AC is equals to sigma S into S. So what I'm going to do, I'm going to calculate area of copper and area of steel. Okay, and then whatever the areas we do have, from that I will be calculating the relationship between sigma C and sigma S. So let us start. Let us start. I do have sigma C and sigma S. So how to calculate area of steel? Can anybody tell me how to calculate area of steel? Can anybody tell me how to calculate area of steel? How to calculate area of steel? Please tell me. How to calculate area of steel? Area of steel is equals to sigma S as it is. So area of steel is equals to pi by 4. So still it is a hollow tube. So pi by 4 into dO square minus di square. Let us put the value pi by 4 dO square minus di square. Pi by 4 into dO square minus di square. Please go ahead and calculate the value of area of steel. 190. 190. Bagul, what is that 190? Bagul.
Delta T, sir.
Delta T. Okay, correct. So right now what I'm going to do, I'm going to put the relationship between sigma S and sigma C. For that I need a AS and AC. So we're going to calculate the area of steel and area of copper. So please calculate the area of steel and tell me the answers. So area of steel, as steel is a hollow. This is a hollow. So pi by 4 dO square minus di square will be the area. So please tell me the area. Look at the formula and calculate the answer. Tell me the answer. Done calculations. Area of Saurabh Devre is saying, Nilesh is saying 192. Saurabh is saying 1306. Sahil is saying, Saurabh, I guess you were wrong because so many students are saying 392. So I'm going with the 392. 392.69. So I'm going to put the value of 392. I'm going to put the value of 392.69 mm square. Now this is area of steel. So how to calculate area of copper? Pi by 4 into d square. So how much d is a 15. So pi by 4 into 15 square is the area of pi by 4 into 15 square is the area of copper. So go ahead and calculate the value of um, area of copper. Pi by 4 into area of copper. Tell me the answer. 176.71. Okay, so many students are saying 176.71. So I'm going to pick this and I agree with you. I trust on you. So I have put the value as a 176.71 mm square is the answer. Very good. Now just put the values in that equation, that is sigma c into AC, that is 176.71 and is equals to sigma s into 392.69. And tell me the relationship between in between AS and sigma c and sigma s.
No.
Tell me the answers. Anjali Santi Singh, 176.71. What you have to do, you have to put the values of both the area in that equation and you have to tell me the relationship between sigma c and AC. Pick the value of both AS and AC, put in that and tell me the relationship between AC and sigma c. Fast. You have to put the values of both answer in that equation only. Finish. Easy. You have to put both the areas and put in that. Sigma c is equals to what? How much sigma s? Be fast. Krishna Nikam is saying 0.22. Let me check the answer. It is okay. Sigma c is equals to 0.22 sigma s. Krishna, whatever the answer given by Krishna Nikam, it is perfectly correct. Whatever the answer given by Krishna Nikam, it is perfectly correct. Good. 0.22. Anybody else? Krishna Nikam is very fast. Good. Now, once we do have a relationship between sigma c and sigma s, now what they told us to identify? They told us to identify the individual values of sigma s and sigma c. Now what I'm going to do, we do have one more equation, that is this is the equation. I'm going to put that equation. I'm going to use that equation over here. I'm going to replace the terms that I know. Okay, so let us start. So sigma c is equals to 0.22 sigma s. So I'm going to put this is, I'm going to copy this equation, copy, and I'm going to press this. Sigma c is equals to, so I'm going to replace sigma c as 0.22 sigma s. Okay, and one more thing is, what is the value of sigma s? So sigma s is equals to 2.1 into 10 raised to 5. Sigma c is equals to 10 raised to 5. Okay. Then delta t. What is delta t? 190 we have just calculated. So I'm going to put the values that I know. Then alpha c and alpha s. So alpha c and alpha s. So alpha c is equals to this much. I'm going to pick this. I'm going to pick this and copy, paste. Then I'm going to pick this term. Copy. I'm going to pick them, put that in that. So I have replaced all the values by means of the numericals. So first what you do, you just do that much calculations and tell me the answers. Then we will look for this, what to do with that. Else you can go and identify. Only there is only one unknown term, sigma c, sigma h is unknown only. You can rearrange and you can tell me the answers, else you can just tell me the answer for this much of equation. Tell me the answers of this much of equation. Everybody has to do the calculations, huh? Nobody will stay isolated. Everybody, those who have calculated this, be aware it is 0.22 or 2.22. You have to check. Huh? Somewhere it is given as 0.2.22. Everybody has to be very much aware. Are you calculating now? Is it zero? It is 0.22 or 2.22. Everybody has to check it. Sile Dangi 2.22. Okay. I have its value 2.22 somewhere. So everybody has to be very much aware. It is 2.20. 2.22. Here I'm going to put it is 2.22. No, 2.22. Krishna Nikam, you are somewhere wrong. Okay, very good. Child Dangi and Bagulum. Very good. Means you are calculating. Now tell me the answer of that much. Tell me fast.
Minus 7.6 into 10 raised to minus 4.
Okay, very good. Somebody is saying, okay, silent. I guess so many people are saying this is the answer. So I'm going to put this copy and I'm going to paste this 11.10. Okay, it is actually alpha c minus alpha s. No? So I have to I have put the value wrongly, so it should be like this. It should be like this, no? It should be like this, no? It should be like this. Now take this 15 into 10 raised to minus 6 minus of 11 into 10 raised to minus 6. It is 10 into 10 raised to 6 into 190. It is 7.6 into 10 raised to, okay, perfect answer. 7.6 into 10 raised to minus 4 is the answer. Huh? Now here, what I'm going to do, I'm going to make a common as a sigma c. Sigma c I'm going to withdraw as a common. If I withdraw, so 1 divided by 2.1 into 10 raised to 5. So 1 divided by 2.1 into 10 raised to 5. It is 4.76 into 10 raised to minus 6. Okay, this is the first value. Everybody has to calculate now. Plus 2.22 divided by 10 raised to 5. So it is 2.22 into 10 raised to 5. So next step would be the addition of both. Plus 4.7610 into 10 raised to minus 6. It is 1.08 into 10 raised to minus 4 of sigma. Yes, is equals to this much. Now the ratio of both. (7.6) into 10 raised to minus 4 divided by answer, it is equals to how much? It is equal to 7.0328 of sigma. Let us take the answer. Everybody has to take the answer. If you right or wrong, tell me. It is right or wrong, tell me. Everybody has to tell me. 7.4. Everybody has to calculate the things. Sigma c is equals to 2.22 into 2.22 into 2.22 into 7.0328, 15.6128. This answer I have with me, but what is the you answer? Tell me in the chat box, or you can unmute. Let me check the answer. My answers are something different, and the answers we have calculated is something different. 18. What is that 18? Okay, so sigma still they have taken as 18, and what is our Alpha of steel is 18. And what we have taken alpha? So alpha as we have taken as 15. Okay, so our answers, these answers are correct. Don't have issue. Let us check the answer. Huh? These are my calculated answers. What is yours? Tell me in the chat box. These are the mine answer. What about your answer? Tell me in the chat box. This is right or wrong. Everybody has to calculate. Sigma S is equals to 28.18. 28.18 sigma S. So my answer is wrong. Sigma S. Why it is so? What is wrong here? It is correct. This is correct or wrong? Right or wrong? Sahil Dangi, please unmute and talk to me. Sahil Dangi, please unmute yourself.
हेलो सर.
मेरा आंसर 0.2696 आया इंटू
आप-
10 पावर -4 सिग्मा एच.
ये सिग्मा एस की बात कर रहा हूँ. 28.18 आपने जो दिया ना,
हाँ सर, ये आया.
यही आ रहा है क्या आपका 28.18?
यस सर.
हाँ, तो यहाँ पर चेक करो. दिस इज राइट. 7.6 इंटू 10⁻⁻⁴.
सर ये स्टार्टिंग में सिग्मा एस इंटू 4.76
हाँ, यहाँ पर क्या
10
होगा?
पावर -6 नहीं आएगा ना?
तो कितना आएगा? लेट मी चेक. 1 डिवाइडेड बाय 2.1 इंटू 10⁻⁵. 4.76 into 10⁻⁻⁶. Correct, beta. See what we have done. We have make common as a sigma s. Okay. तो जब यहां से सिग्मा एस निकलता है तो ये क्या बचता है? 1 डिवाइडेड बाय 2.1 into 10⁻⁵. So 1 divided by 2.1 into 10⁻⁵ will be equals to this. Similarly यहाँ पर क्या बनेगा? यहाँ से अगर सिग्मा एस निकल रहा है तो यहाँ पे क्या बनेगा? 2.22 डिवाइडेड बाय 10⁻⁵. तो बट अब यहाँ पे दिस शुड बी 10⁻⁻⁵ ना. 2.22 divided by 10⁻⁵. So it is 2.22 to 10⁻⁻⁵. 4.7610 into 10⁻⁻⁶ plus 2.22 into 10⁻⁻⁵. So it is 2. Okay, so here it is nothing but it is 2.696 into 10⁻⁻⁵. Okay. And the thing is 7.6 into 10⁻⁻⁴ divided by answer. So it is correct. 28.18. Correct. Is 28.18. Everybody has to calculate. Huh? So again here 28.18. Then it will be 28.18 into 2.22. So it is 62 point. Is 62.579. Correct now? Now it is okay. 28 and 62. It is something different. Why it is so? It is 140. What is that 140? Delta T, the temperature. This is different numerical. So what is that? 30, 40. This is 49 and 109.651. Here it is 49. हाँ, इनका ये अलग है ना, इन्होंने 18 लिया है, हम लोगों ने 15 लिया है. Okay. Total. Please cross verify the numerical. Side Dangi. Now the answers are okay. Sigma is Anjali Sons. No. See, I have given the calculation in over here in the simple way. Okay. This is, I guess this step is clear to everybody. Yeah. In the second step, what I have done, I have just put the values in this step. And now over here, this is make it more simple. Make it more simple. Okay. I'm going to make it more simple. Everybody has to calculate so that it is very easy to understand for everyone. Now it is open. Now again it is sorted. Take the answers. Please take the answers. Now it is okay for you or not. Anjali sent now it is okay.
Yes, sir.
Good. Sahil Dangi. Sahil Dangi. Oh my God! It is 12:32.
Sir.
Okay, Abhi. Understood. Is there any correction?
No, sir.
Okay. Now I guess it is clear to everybody. Please ping it if it is clear to each one of you in the chat box. Right now it is 12:32. Somebody will wait for you at 1, na? 12:40. If the numerical is clear to everybody, please ping in the chat box. Is it possible for everybody to? Okay, Nikam Pratik. Babu. Okay, good. Okay, good. Okay, so these are the answers. These are the answers. Now we'll be conducting this numerical. Okay, the numerical will be the same. Shall I arrange one more extra lecture in the afternoon time? Is it possible to attend to everybody? Yes or no? Okay, fine. I'm going to stop today's recording.